So welcome all. In these animations, I am going to show you how the deflection and slope changes in cantilever beam. Below you find here a cantilever, a real example, and in derivation we had seen maximum deflection is PL cube upon 3i and slope is PL square upon 2ei. Okay, in animation see here, stop the animations. P is the load acting here at the end is 0 currently kilonewton, so in deflections and slope are very minimum, nothing, 0 value. So you can note from here also del theta are 0 here. Okay, now as you are increasing the p value, see the deflection and theta value is increasing. See, at the same time you can find the deflection over at the free end also. Okay, as you are increasing the p, see the values of deflection and slope are changing or increasing. Okay, since p and del are directly proportional, in formula we had seen. As you are changing the length, go to the decreased length, minimum length it is now. Okay, since p, del, deflection and theta are having the directly proportional, so lesser is the L value, lesser will be the del and theta. Okay, as you are increasing the L value, see what is happening, it is increasing, both are increasing, slope and deflections are increasing. Keep the value somewhere here. Okay, this is E. E is what? Depending upon the material type, whether it is steel. For the steel it is 200 GPa, aluminum it is 69, titanium it is 116, wood we are having the 11 GPa. So out of these four materials we are having steel maximum value of E and wood minimum most value. Okay, so for keeping all these variables constant, you can see here steel gives the lesser or least deflections, 111 mm 5 radian. Okay, now choose the wood, see what is happening. Now del value increased, theta increased. So what does it mean? That P and E are having the inversely proportional. This is having the inversely proportional. Theta and also having the inversely proportional. So for the wood case, lesser is the E value, higher will be the theta or slope value. Now similarly here I section for the rectangular we are having 6.70 rectangular, circular 7 little higher compared to rectangle, beam again much higher. Okay, so increasing order of I section, I second area of moment of inertia value is okay. As rectangular I am choosing, so we are getting deflections approx 200, okay, and slope 100. Rectangular it is, see here, for rectangular 136 and theta is 6. Circular now see changed, means decreased. Earlier for rectangle it was 136, for circular 115, decreased now. For rectangular slope was 6.2, circular 5.2, decreased. For the I sections, if I compare circular and I section, circular it is 115, I 76, decreased. Theta del value, deflection. Circular theta is 5.2, I 3.4. What does it means? As we are choosing the I beam section, okay, we will get lesser deflection value and lesser theta value. Okay, so play it auto mode. See here, the deflections in real time you can get the change the E value. So play in auto mode. I you are changing. Okay. So in this way you can see that how the deflection and slope values are changing. Okay, you can change the length as you are changing. Check the length minimum. See, the deflections is very minimum and slope is also very small. Okay, now increase the L value. See, the deflection got very high. Theta is also has become very high. Okay, as the length you have increased. Now let's set at here. Okay, E value you are set it very less for the wood case. See here. So maximum del and theta you are getting here. Okay, now set E to the very high value. See, very minimum value of deflection and slope you will get. Okay, let's set at here, or take example of aluminum 69 GPa, which is having universal value. Now set I minimum most. Okay, play in auto mode, set. See what is the value of del and theta. Inversely proportional na? Del inversely proportional to I, theta is also inversely proportional to I. So you can see that maximum del and maximum theta you are getting here. Okay, now increase the I value. Okay, now start playing the animations. See, very small value of del and theta you are getting here. Okay, so what you in here, so you can easily find out how different variables P, L, E and I are affecting the deflection and slope of in cantilever beam. So thank you all.